Now see the next part, part 1 of solid state. Part 1, solid state. See the first question asked in 2021 NEET. So first question is correct option for the type of body center unit cell in all 14 types of Brevis lattice. It is talking about body centered BC. Right, it is called as body centered. Right, so there are total 14 types of Brevis lattice. Right, 14 types of Brevis lattice. Brevis lattice. So crystal form is called as Brevis lattice unit cell. It is asked in 2021. So first option is, that is 3. So total body center lying in the 14 crystal is 3. Right. So in body center unit cell, atoms are arranged in corner and body centered. So how will it will be looking? So this is your smallest crystal unit cell, right? So normally atoms are present at the corner of this atom, right? So total 8 corners are there. So total 8 atoms should be placed. But for the body centered, one atom is placed between the body, right? Here, whole body. So total possibility is 3. So body center unit cell is present in 3 crystal systems. So cubic, tetragonal and orthorhombics. So body centered will be of 3 types, right? So when one atom is kept between this cubic unit cell. So this is first type will be cubic, next will be tetragonal, and third will be the orthorhombic. So these are the 3 types of body centered cubic unit cell. So it is also called as BCC, body centered cubic unit cell. I will write the full form also, body centered cubic unit cell. Now see the next second question. So in right option for the number of tetrahedral and octahedral voids in hexagonal primitive unit cell. So it is talking about tetrahedral and octahedral voids, right? So there are 2 types of voids forming tetrahedral and octahedral in hexagonal primitive unit cell. Hexagonal primitive unit cell. So in hexagonal primitive unit cells, you have to find the voids, tetrahedral and octahedral, asked in again in 2021. So see the answer for this one. In hexagonal primitive unit cell contains 6 atoms in the crystal lattice, right? So hexagonal stands for 6. So total 6 atom will be there, right? So it can be in short form can be written as HCP, hexagonal cubic close packing, right? So number of octahedral will be equal to the number of atoms. So when n is 6, octahedral void will be same. It is equal to the number of atoms. So it will be tetrahedral voids. How many will be there? 6. So tetrahedral voids is nothing but it is equal to the number of atoms present in it. Understood? And tetrahedral voids will be the 2 times. So tetrahedral voids will be equal to 2n. So it will be total 2 into 6. That is total 12 voids are there. So write the answer. So how will you find octahedral voids in any lattice? It will be equal to n only, number of atoms. Or tetrahedral voids will be 2 times of octahedral voids. So remember the important points. Now look at the question number 3. An element has a body centered cubic. So it is BC's body centered cubic, a structure with cell edge of. So edge length is given 288 picometer. Atomic radius you have to find. R value you have to find in BCC. So it is directly based on the formula. It is also asked in 2020. So please remember the relation for BCC between A and R. So it is nothing but root 3A equal to 4R. Right. So I will explain. Suppose this is your cubic unit cell. It is looking like cube, right? So in cube, length equal to breadth equal to height. So I will take here A, right? All length, breadth and height is same here. So it is your A. A is called as edge length. Edge length. Understood? Now I will keep the atom here on the corner of this cube. Understood? So see, suppose this is your edge length A. Now I will put one atom to the each vertices. So total, right? Here radius will become A equal to R plus R. So it will be 2R. But for the body centered cubic unit cell, one atom is also kept here, right? So when we attach this one, so it will be equal to 4R, because this is like this. One atom is here, one atom is here, and one atom is kept between these two. So this is your R, and this will be R plus R. Total 2R, right? And this is also R. So it will be how much? 4R, 4R are there, right? So it is also equal to root 3A by 4. So this is the relation between BCC lattice. So you have to find the R value, radius, it is asked. So R is nothing but it is root 3A upon 4. I will take 4 on in this denominator part. Then you have to put the value root 3 and A value we know 288 picometer divided by 4. So divide this one. So it will be 7 4 ja 28, and this will be the 2 times. So answer will be 72 root 3 picometer radius value. Understood? Please write this one then. Now see the next sum, that is question number 4. So it will be a compound is formed by cation and anion. So suppose compound X is there. So it is formed by cation and anion. Anion forms hexagonal cubic close packing. So A is nothing but your anion. So it is following SCP, hexagonal cubic close packing, and carry the occupy the cation occupies 75% of the lattice of octahedral voids. Octahedral voids. Right. So formula of the compound is. So it is asked in 2019. See the explanation. Hexacubic close packing. So anion will be how many? 6 atoms will be there in hexagonal cubic close packing. So you know the anion value now, negative part, right? Now see the cationic part. So it is 75% of that. So it will be 75 upon 100 into so it will be 3 upon 4. It is nothing but it is 2 into this will be the 3. It is 9 by 2, right? Now formula for X is C value, right? And A value. C value we have got. This value is C. So it is nothing but it is 9 by 2. And anion value we know, that is 6. Right. So to simplify this, I will multiply with 2. So it will be 9 by 2 into 2, 6 into 2. So your answer will be C. This 2 and 2 will get cancelled. So it will be C9H12. Right. More you can also simplify with the dividing by 3. So it will be C3H4, right? After dividing by 3. So this will be the final answer. This is A now, so I am writing H here. So it will be C3A4. This is the answer for the molecular formula. Next question is question number 5. So in calcium fluoride, so next compound is calcium fluoride. So it is nothing but it is CF2 in the chemical formula, having the fluoride structure, coordination of number 4 calcium ion. So calcium is nothing but it is Ca2 plus and fluoride is 2F minus will be, right? So you have to find the coordination number in a structure form. So in fluoride structure, Ca2 plus ions are in the FCC center cubic unit cell. So it is in FCC, face centered cubic unit cell, right? So I will explain for FCC. It will be the cubic unit cell, right? So total how many faces of this cube? So there are total 6 faces, right? One is front, second is back, this will be the top, next will be the bottom, next will be the side, this is the adjacent side. So total 6 faces, right? So 6 faces in the cubic unit cell. Right, so Ca2 plus is concentrated with 4F minus, so below to it and above to it. So there are total Ca2 plus has coordination number 8. 4 ions are there now. So 4, 2 plus, so it will be 4 into 2, so it will be 8. Right, and F will be the 4. F minus will be the 4. So this will be the value. So coordination number of 4, F minus is 4 and for Cn is 8. Now see the next sum, 6th question number. So vacant space in BCC it is asking. So it is direct based question. So vacant orbital or vacant space in BCC, body centered cubic unit cell. Right. So see, for BCC packing efficiency is 68%. It is called packing efficiency. Packing efficiency. It is 68%. So suppose this is your cubic unit cell, 68% space is occupied, right? Occupied only. How many spaces are required? Void are empty. It is nothing but 100 minus 68. So how much it is? This will be 2, 9 minus 6 is 3. So 32% is space is empty in BCC. So please remember this 68% space is occupied, right? And vacant space is 32%. So it is direct based question. And for other it will be different, right? Like simple cubic. So it is 56% occupied, right? And for FCC it is 74% occupied. So unoccupied you can find directly 100 minus 74. So it will be how much? It is 6. So this will be 26. It is void, right? And for this one is 100 minus 56. So how many empty spaces are there? It will be 4. This is 4. So 44 space. Empty spaces are there in simple cubic. SC means simple cubic. FCC means face centered cubic unit cell. Face centered cubic unit cell. So please remember this one. Now see the next question. Question number 7. Number of carbon atom per unit cell of diamond unit cell. So it is talking about carbon which is present in diamond, right? So it is asked in 2000 13. So see, diamond is like zinc blade. So diamond structure will be like ZnS. So its name is Zn for zinc, and this will be the blend. So zinc blend, right? So carbon forming CCP, cubic close packing. CCP means cubic close packing. Understood? And CCP comes, follow the rule FCC, face centered cubic unit cell, right? So it also occupy half of the tetrahedral voids. So tetrahedral voids it follow. So it will be the 2 times of the octahedral voids, right? So total number of atoms it is following is 8 into 1 upon 8. So why 8 into 8? Because in cubic unit cell total at 8 atoms at the vertices, right? So this 1 2 3 4 5 6 7 8, this will be the 8. So 8 atoms, and 8, this unit is containing 1/8 part of that, so it is 8 into 1 upon 8 plus 6 faces, so it will be 6 into 1 upon 2. Total how many faces are there in the cubic unit cell? 6 face, right? In the previous question I have explained it, right? So that contribution will be 1 upon 2. So simplify this one, and it is in tetrahedral void. So 4 atoms are there, right? So now add the value. So this is 1, this is 3, this is 4. So how many? Total number of carbon atom? Total 8, right? This force comes for tetrahedral voids. So total 8 carbon atoms are there in diamond, right? So please remember this one. Now see the next question, number 8. Number of octahedral voids per atom present in cubic close packed. So it is talking about octahedral voids. So you have to find the just number of atoms. So it is equal to number of atoms present in CCP, cubic close packing. So it follow the FCC, right? CCP stands for what? Face center cubic unit cell. So total number of octahedral voids will be 1. So N is 1 here, right? For which one? एक second. For question number 8 now, you're solving. So it will be 1, right? So octahedral voids follow the CCP rule, cubic close packing. So remember the full form also. It is cubic close packed.